This is the introductory video to graphing quadratic functions. We're going to go over the basics on how to graph quadratic functions in standard form. On the next slide, I have some notes on some basic properties of quadratic functions in standard form. Please copy them down. I'm not going to go over it on the slide, but I will go over the information during the example. So just make sure that you write it down so that you can see it as I'm explaining the next couple examples. So here's the parent function for quadratic functions in general. The name of the graph is called a parabola. So make sure that you start referring to the graph as a parabola. Okay, it's not a U, it's a parabola. The things that you need to know about it is where the vertex is, where your y-intercept is, and where your axis of symmetry is. Now with your parent function, your axis of symmetry and your y-intercept and your vertex are all on the same line here. They all are on the y-axis. Okay, so my vertex here is actually the point 0, 0. Okay, it's at the origin. Your axis of symmetry is the vertical line x equals whatever x is. So this should be just a review. Remember, it's just whatever that value is there. So x equals 0. That's that red line, that red dashed line that I drew. And then your y-intercept, okay, it's the point where it crosses the y-axis. Now, x is always 0 on whatever your y-axis or your y-intercept is, because no matter what point you choose on this y-axis, x is always 0. So at this point here, that's the point, 0, 7. This point right here is the point 0, 6. And you can choose any point on this axis, and you see that x is going to be 0. So the value for x at that point is 0, -2. So that's why we can just kind of set it up where your y-intercept, x is always 0, and then your y value is whatever c is. So if you're looking at this parent function over here, x squared, b and c are 0. So plus 0x plus 0. Okay, I mean that's the same thing here. So a is equal to 1, b is equal to 0, and c is also equal to 0. So when you're writing your y-intercept, your value for c here is 0. And you can see here on the graph, it crosses the y-axis at the origin, so it's going to be 0. A few things from the previous slide that you need to know. If a is greater than 0, your graph is going to open upwards. So your parabola opens upwards, your vertex is going to be down here at the bottom, and we call that a minimum. Okay, so if I tell you this quadratic function has a minimum, then you should already picture this in your head. You should know that it's going to be opening upwards. If a is less than 0, which means it's a negative number, it's going to open down. Okay, and your vertex is going to be up here at the top, which means that it's a maximum. Okay, so if I'm saying the maximum of a quadratic function, then automatically you should picture an upside down parabola when I'm talking about that. In the next couple of examples, I'll show you how to find your axis of symmetry, your vertex, and your y-intercept of quadratic functions. So here we have negative x squared minus 2x plus 6. So let's just find our a, b, and c. A is negative 1, b is negative 2, and c is equal to 6. So right away you see that a is less than 1. It's a negative, which means it's going to open downwards. And that vertex there is going to be a maximum. And this is just terminology that you need to know. So let's go ahead and find our vertex. Now, when you saw this over there, I'm sure it confused you. One thing that you need to know is that it should be negative b over 2a here on the second half over here. So in your notes, make sure that you fix that. So let's find the vertex. Remember, your vertex is a point, x, y. Okay, so when we find this point, we have to find the x value first, and in order to find the x value of the point, you use the formula negative b over 2a. Okay, so let's just go ahead and fill in our values. Make sure that you use parentheses so that you catch any negatives. Okay, so our b is -2, so there you have a double negative over 2 times a, which is -1. So just simplify, negative times -2 is +2, 2 times -1 is -2, gives you -1. So your x value of your vertex is -1. Now this confusing part over here, which is f of -b over 2a, what that means is just plug in your x value into the equation. So remember when we were evaluating functions for a number, we would just plug it in. That's all you're doing here. Remember, your left-hand side doesn't change. You always want to use your parentheses when evaluating your function so that you catch any double negatives. And then you're just going to plug in your x value. So our x value is -1, -1, and then just go ahead and evaluate it. So -1 squared is 1. -2 times -1 is +2. Plus 6. And you can actually just plug this all into your calculator at once if you want to. So -1 plus 2 is 1, plus 6 is 7. Okay, so that is your y value for your vertex. So our vertex is going to be at the point -1, 7. Okay, so that's where we're going to plot that point. I'm going to go by 2's here. So 2, 4, 6, 8, -2, -4, -6, -8. So our vertex is at the point -1, +7. So right here. Okay, now remember, we know that our parabola is going to be opening downwards. Our axis of symmetry. Okay, there's really no math that you need to do here for this because you already did it. Our axis of symmetry is the line x is equal to -b over 2a. So we already know what that is. That's x equals -1. Okay, so our axis of symmetry is the vertical line that crosses through your vertex. Okay, and then last but not least, we have our y-intercept, which is the point 0, whatever c is. Well, c is 6. Okay, no math, just plugging in numbers. So we can plot that point as well, 0, 6. Okay, now the cool thing about the axis of symmetry is it allows us to kind of copy points that are reflected across. So if I have this point for my y-intercept, which is 0, -6, I know that there's another point the exact same distance on the other side. Okay, that's why parabolas are symmetric, okay, these quadratic functions. So when we graph it, I can actually just move the same amount of distance from my x-intercept in the opposite direction on that line. So I can actually plot another point right there. So I have 3 points right here, and you can just connect them to graph your parabola. So in the next video, we're going to find 2 more points, which will be the zeros. Okay, and you know how to find the zeros. We've been doing this the whole chapter. You can do it by factoring, completing the square, or whatever. So in the next video, we'll actually be finding those values. Okay, those are your zeros, your solution. But for right now, we're not going to worry about it. Here's our last example for this section. If you understand it, feel free to move on to the homework. It's already been assigned to you. Or if you have questions, watch this or let me know tomorrow. So let's go ahead and identify our A is 2, B is -12, C is 22. Okay, A is positive, so we know that it's going to open upwards. Our vertex is going to be at the bottom. It's going to be a minimum. Okay, so let's go ahead and find our vertex. Remember, it's the point x, y. Okay, our x value is found by using the equation -b over 2a. use your parentheses. Oops, that's negative 12 there. So we have negative b over 2 times a. B is negative 12. A is 2. Double negatives give you positive 12. 2 times 2 gives you 4. 3. Okay, so our x value for our vertex is 3. Now we're going to evaluate the function at 3. So we have 2x squared minus 12 times x plus 22. Plug in your values for x. Okay. 3 squared is 9. 12 times 3 is 36. Okay, so we have 18 minus 36 plus 22. And you can actually plug everything into your calculator, guys. So, you can figure it out all at once. So that's going to give us 4. 9 times 2 is 18. Yeah, okay. So that is our y value for our vertex. So our vertex is at the point 3, 4. So 1, 2, 3, 1, 2, 3, 4. We know it's going to open upwards. Let's go by 2's on this graph. 2, 4, 6, 8. Okay, so now we need to find our axis of symmetry. Again, no math. You know it's the vertical line x is equal to whatever this value is. And your y-intercept, also no math, that's the point 0, whatever c is, that's 22. And then you plot them. Okay, so we can plot our axis of symmetry. That's going to fit here. Okay, so that's the line x equals 3. Now we're not actually going to be able to plot our y-intercept. That's going to be way off the graph, up at the top. But if it did, let's just say it's over here. Okay, remember with our axis of symmetry, you can plot it the same distance on the other side. Okay, so then you just connect your dots. Later on in the next video, we will be finding the zeros. Here there will be none because it doesn't cross the y-axis, or the x-axis, excuse me. So there you go. There's your graph, nice and pretty. You have your y-intercept, which you can't see on this graph because it doesn't fit. Your 2 points, your axis of symmetry, and your vertex, which you know is a minimum. So your vertex is at the point 3, 4. Okay. If you have any questions, let me know. Feel free to go on to the next video if you want to.